Today we're going to be graphing linear equations using the slope-intercept form. In our last chapter, we have been graphing already, and there are two ways that we have already learned to graph a linear function. If you remember correctly, that was making a t-chart and finding the x and y-intercept. So just in a quick review, we can graph a linear function by making a t-chart, and when given an equation, right here, all we have to do is fill in some numbers for the domain or for the x, as you can see in the chart right here, plug them into the equation, and solve for y, which creates for us four ordered pairs. I'm just flipping through here to show you what we've already been learning. We can now graph those four ordered pairs, and they should create a straight line. So that's what we did in our last chapter. We also graphed by finding the x and y-intercept. And as a review, to graph by finding the x-intercept, we plugged in 0 for y. When you do that, the y basically goes away. You solve for x, and that gives you an ordered pair of 4, 0. If we plug in 0 for x, we will solve for y, and that gives us the ordered pair 0, negative 2. So again, this is just review, reminding you of what we did in our last unit. Today we're going to be learning a third way to graph using the slope-intercept form. Here is the slope-intercept form. It has two letters other than the x and y, and that is an m and a b. The m always stands for the slope of the line, so you're always going to find the slope right in front of the x term, and the b stands for the y-intercept. This is where we get the name slope-intercept form, because it contains both the slope and the y-intercept. And if you know both of these, you should be able to graph a linear function. So first, let's just practice writing an equation in slope-intercept form. If you know the slope of 1/3 and you know the y-intercept, all you have to do is take our equation y equals mx plus b and plug in the numbers. So the slope goes in for the m, the 6 goes in for the y-intercept, and our equation would simply be y equals 1/3 x plus 6. For more practice, with our equation y equals mx plus b, if the slope is 0, well, any number times 0 is 0, so we don't need the slope on this one because there's a 0 slope. And we fill in a negative 5 to the y-intercept, so that leaves us with y equals negative 5, which is a linear equation. You just go down to y to negative 5 on the y-axis and draw a horizontal line which has a 0 slope. 0 slope. And with practice here, if we have a slope of negative 12 and a y-intercept of negative 1/2, and we plug those in, that's negative 12x minus 1/2. Now with a slope, you need a rise and a run. So if we have a whole number or an integer, you'll have to make it into a fraction by putting it over 1, so that the rise is negative 12 and the run is a positive 1. You have to think of it that way when you're graphing it. So let's practice graphing. If we have an equation with a slope of negative 2/3 and a y-intercept of 1, that would give us the equation y equals negative 2/3 x plus 1. We just plugged in the numbers. Now when graphing, we always begin with the y-intercept. This tells us where the line crosses the y-axis. So we simply go to the y-axis and put a point at a positive 1. There's our first point that we need. Now in order to graph, we need 2 points. Now from the y-intercept, we can do the slope. When it is a negative slope, you can think of it two ways. You can put that negative sign on the rise, or you can put the negative sign on the run. This would be down 2 and to the right 3. This one is up 2 and to the left 3. But both of those points are going to be along the same line. Let's just try both of them to see how that works. For negative 2/3, if we put the negative on the rise, we're going to start at the y-intercept and go down 2. I have the arrows here. down 2, to the right 3, and that gives us a point right there. If we use the other one, we start at the y-intercept and we go up 2, 1, 2, over 3. And again, this point is within the same line. And it's a negative slope, as we see right here. So you see it going downhill. That's what negative slopes do. Slope of negative 2 and a y-intercept of 4. Our equation would be negative 2x plus 4. We have to think of the slope as a rise and a run, so we put that over 1. We always begin at the y-intercept, which is 4. From the y-intercept on the slope, we can either go down 2 to the right 1, or we can go up 2 and to the left 1. On this one, I'm just going to go down 2 to the right 1. There's my second point. And if you're more comfortable, you can do this slope over and over again. I could go down 2 to the right 1 again, down 2 to the right 1 again. My line's a little off, but you can do the slope over and over again. Sometimes the equation is not written in slope-intercept form. Slope-intercept form means that the y is by itself on the left side of the equation. So before we can graph it, we're going to have to rewrite the equation in slope-intercept form. So if we want to get the y by itself, here's the form we want it in. We want the y on the left. We want the x term to come first, and then we want the constant or the y-intercept to be last. Well, the first thing we're going to do is move the x term, and we want it right after the equal sign. So we're going to tell this guy to scoot over because he's in our place. When you move a term from one side of the equation or the other, we use inverse operations. So this makes it really simple if you remember that when you move it from one side to the other, you're just changing the sign. We have a negative 6x, so we have to do a positive 6x for that to cancel out. So when you move that over, it would be a positive 6x from one side to the other. We told negative 9 to just move over, and now we have it. Oops, I forgot the 3 in front. We still have a 3 multiplied by the y. But we did move the 6x from the left side of the equation to the right side of the equation by changing the sign. Y is still not by itself because it's being multiplied by 3. So we want to divide all 3 parts by 3. When we do that, y equals 2x minus 3. Of course, the slope right here would be 2 over 1, or a rise of 2 and a run of 1. We were practicing for this when we were solving for variables in our previous chapter. It just shows you the steps again. Okay, in this equation again, we want to get it in slope-intercept form. So we want the y by itself on the left side of the equation. So first we want to move the x term over here and put it right after the equal sign. If we do that, we would simply have negative 4y left on the left side. The x becomes negative because we have to subtract x on both sides. And I also did it in the same step. I also moved the 8 to the other side of the equation. I did both in the same step, and you can do that as well. We still did not have y by itself, so now we need to divide all 3 parts by a negative 4. Now, if you look at the slope right here, we have a negative x divided by a negative 4. We always have an imaginary 1, or an invisible 1, sorry, not imaginary, but invisible 1 in front of the x. We have 2 negatives, so that would be a positive 1/4 x. You just have to learn how to recognize that. So our equation would be y equals 1/4 x minus 2, because 8 divided by negative 4 is a negative 2. So our slope is 1/4, and our y-intercept is negative 2. This time, we have an x term on both sides of the equation. So we're going to have to subtract that negative 1x from both sides of the equation. When we do that, we get 5y equals 7x minus 20. Now, in order to get y by itself, we're going to have to divide all 3 parts by 5. When you do that, we have y equals 7/5 x minus 4. So the slope is 7/5, and the y-intercept is -4. If you're taking notes, this starts the note page. We have an equation here at the top. If you look, it is already in slope-intercept form because y is by itself on the left side of the equation. And we have the steps written over here of how you're going to graph it. First, you need to check to see if it is written in slope-intercept form. Ours already is. Second step, and this is a step you can do mentally, but we're going to do it on our notes. Just to make sure you can identify the slope and the y-intercept. Always know that the slope is in front of the x, so our slope is 1/4, and our y-intercept is at the end, or the constant, that is -6. Now we're ready to graph. We always start graphing with the y-intercept. Always start at the end with a -6. Our y-intercept is -6, so you go to the y-axis, down to -6, and you put a point. From the y-axis, we are going to do our slope of 1 to 4, which means to rise 1 and go to the right 4. If you wanted to, you could do that over and over again. Rise 1, to the left 4. 4, put another point. These should all be in the same line if you like to have more than one or more than 2 points to graph from. In our next example, we're going to follow the same steps. First step is to check to see if it's in slope-intercept form. This one is not. We need to move the x term over to the right side and scoot the 2 over. When we do that, we would have an equation of y equals a positive 4x, because when we move the -4x from one side to the other, we have the opposite sign, and we scooted the 2 over. Now we can identify the slope as 4, or 4/1, so we're going to rise 4 and go to the right 1. And our y-intercept is a positive 2. So we can go to the graph. We can graph our y-intercept of a positive 2. Then we can go up 4 to the right 1 and put a point. If you want to do, you could go up 4 and to the right again 1, and you could put another point if you'd like to have more than 2 points. And then you graph it. Our next example is another equation that is also not in slope-intercept form. So again, we want to move this x term over here to the right side and scoot the -9 over. When we do that, we have 3y equals a -6x. And then we scooted the 9 over, so -9. Y is still not by itself, so we have to divide all 3 parts by 3. When you do that, we have y equals a -2x minus 3. We start graphing with the y-intercept. So we go to -3, and we put a point on the graph. Our slope we identify as -2/1. So we can either go down 2 and to the right 1, or we can put the negative on the run, and we can go up 2 and to the left 1. Both of those points should be within the same line. I show us going down 2 to the right 1. If we did it the other way, you would go up 2 and to the left 1, and you'd have a point right here. And they're all within the same line. In this example, we have the y-intercept that's on the incorrect side, so we're going to move the positive 4 to the other side by changing its sign, by subtracting 4 on both sides. That gives us an equation of y equals 4/3 x minus 4. That makes our slope 4/3, which is a rise of 4 and a run of 3, and our y-intercept of -4. We always start graphing with our y-intercept, so we put a point at -4. Then we're going to rise 4, go to the right 3, put our point, we have our graph. On this one, you could choose to move the y to the right side. You just need y by itself. So let's see what this would look like if, hey, we had the y on the other side but just got it by itself. Let's start by moving the constant over here. So we'd be subtracting 8 on both sides. When you do that, on this example, I moved it this way. We have 7x minus 9 equals a 3y. Then to get y by itself, we divide all three parts by 3. And when you do that, you get y equals, over on this side, you have 7/3 x minus 3. Now this is slope-intercept form. We just have the equals y on the other side. So if you're not comfortable with it that way, you can just flip it back so that the y is on the left side. These are the same equations. When we start graphing, we start with the y-intercept, which is a -3. This is the other way I showed it when I was doing the PowerPoint. I showed it moving the y to the left side first, which you can do if you prefer doing it that way. Okay, we start with our -3. We have a slope of rise of 7, run of 3, +3, so we go to the right, and we have our line. This is getting pretty lengthy, so I'm going to go ahead and stop right there. I hope this helps you do your assignment today.